Breadboarding and hand wiring is great for starting out with an electronics project, but for deployment, nothing beats a well-made printed circuit board. Coming up in this video, we'll be designing one from start to finish using KiCad. Hey, I'm Trevor Makes, and a common problem I've found with 8-bit computers is replacing old ROM chips, whether due to failures, preservation, or just reducing heat dissipation. Modern 28-pin EPROMs are easy to source, low power, and electronically compatible, but the pinout is somewhat different from the older 24-pin ROMs. In a previous video, I hand-wired an adapter like this, but going forward, I'd like to have a more elegant solution using a printed circuit board. While there are plenty of ready-made adapters available online, I thought this would be a great project to build for a KiCad tutorial video, since the wiring is straightforward and it incorporates both the symbol and footprint editor tools. Don't worry if you're not familiar with 8-bit computers, as this tutorial should be useful for anybody learning KiCad, but for the specific details, we'll be building an adapter board with a socket for a 28C64 EPROM, with headers that will plug into a 2364 ROM socket. And it'll also have some jumpers that can be configured for a 2332 character ROM for either a Commodore 64 or a VIC-20. Anyway, let's get started. So for this video, I'm going to be using KiCad version 8.0.3. We'll start by creating a new project. I'm going to call it ROM adapter. To start off, I'm going to go to the symbol editor because we need to create a couple symbols. Okay, and then first thing we need to do is create a new library inside of our project. I'll call it the same thing, ROM adapter. And what I'm going to do is I'm going to look for the 27C64. Copy that symbol. And then we go to our ROM adapter and we're going to paste that symbol. So that's going to make a local copy of that we can modify. Now for this project I'm actually going to be using a 28C64, but I want to make it work with both, and I just wanted to make sure I had this VPP pin in here, since for the 27C64 this does need to be connected to 5 volts, whereas on the 28C64 it's just a no connect pin. Now the thing that I want to change on this symbol is I want to locate this pin 26, which in the existing symbol is hidden. So we're going to change two things. First is we're going to make it visible, and we're going to change it from an unconnected pin to just a free pin. For the socket adapter, I am going to want to connect this to 5 volts, whereas if we leave it as a no connect pin, we actually can't connect it to anything. Now the second thing that I want to do is go into the symbol properties, and I want to change the footprint from a dip package to a dip socket. And so now I'm going to rename the symbol to a 27C64 socket. Go ahead and save that. Then I'm going to make a second copy of that 27C64 symbol, but this time we're going to change it to a 2364. And so here's the data sheet for the 2364. We can see the difference here is we do not have the programming pin, we don't have the programming voltage pin, and instead of a chip enable and output enable, we only have a single chip select. And also that no connect pin, pin 26, that's not going to be present either. So we can go into the pin table and we can start by removing the pins that are not present. So we'll get rid of output enable, no connect, delete it, programming, delete, and there was also VPP. We can remove this as well. And now we do some renumbering. So we can start with A12. This needs to be changed to 21. And then all of the address pins through the data pins, we need to subtract 2 from each of these. So A7 is going to become 1, A6 is going to become 2, and so on. Okay, so that takes us through all of the data pins. Now we have address 11 will be 18. Address 10 should be 19. chip select is 20, that's correct, but we're going to change it to CS_1. Now we change address 9 to 22, address 8 becomes 23, and finally VCC becomes 24. Okay, all these pins look good. Go back into the symbol properties. We're going to change the value to 2364. And for now, I'm going to change the footprint to a 24-pin socket, but we're going to create a different footprint for this a little bit later. Okay, we'll rename it to 2364 socket. Okay, and that should do it for the two symbols I need. So I'm going to go ahead and close our symbol editor here. And now we're going to go into the schematic editor. So I'll drop in two of those symbols that I just made. We'll do our ROM adapter. We're going to drop in a 27C64 socket. And we'll drop in a 2364 socket. Get these lined up. Okay, and I'm going to start by connecting the address pins and the data pins together. Okay, so there's the data and address pins. So now we create some power symbols. We'll do 2 copies of ground here and here. And we can wire those up. And now we do 5 volts. Okay, so I need to make a little bit more room here. I put these a little too close together, so I'm going to select these and press G to drag them down a bit. I'm going to create quite a bit more room, actually. I think that should be good. And then I'll move the whole thing up a little bit. Okay, I think that should do. Now I need to place another 5 volt. I'm going to place one here. And I'm going to need one over here for this no connect pin, and I'll need another one over here for the 2 programming pins. So go ahead and wire these all up. Okay. Okay. And now that just leaves us with the chip enable and output enable on the 27C64, as well as the chip select on the 2364. Now, the most obvious thing to connect the chip select to is the chip enable. So go ahead and do that first. But the output enable is going to be a little tricky because I'm going to want different behavior depending on if it's replacing a 2364 or if it's replacing a 2332 character generator ROM. And those are going to be different depending on if it's the C64 or the VIC-20. Now, the reason it's a little weird is because on the 2332, the pin 21, rather than being address 12, is actually a second chip select pin. And both of the chip select pins could actually be programmed in the factory to either be active low or active high. And it just so happens that for the Commodore 64 character generator, the second chip select was programmed as active high, but for the VIC-20, it was programmed with active low for chip select 2. On the Commodore 64, it actually always just feeds 5 volts directly into this chip select 2 pin, so it's kind of unused. But on the VIC-20, both of these chip selects are used independently. Chip select 1 is connected to the block 4 signal from the address decoder, while chip select 2 is connected to the address 12 line. And so together they select the lower half of block 4. Now, fortunately, with the 27C64 and the 28C64, we don't have 2 chip enables, but we do have a chip enable and an output enable. The output enable is not exactly a chip enable, but it does work out that both of these need to be pulled low in order to get the ROM to actually output data. And so for the VIC-20 configuration, we can connect both of the chip select pins up to chip enable and output enable. So anyway, I'm going to go ahead and add a solder jumper. We're going to do a 3-way with bridged 1 and 2. Rotate that and we'll put it right here. And so the middle connection of the solder jumper should go to our output enable line. By default, we want the adapter to work for 8K ROMs and for the C64 character generator. So we're going to hook that up to the chip enable line. That way, by default, the chip enable and output enable lines will just be tied together. So whenever the chip select 1 goes low, it will pull the chip enable and output enable low. But for the VIC-20 mode, we'll be able to cut that trace and then solder pins 2 and 3 together. And we're going to have that pad 3 go to address line 12, which I have it marked as A12 here, but for the 2332, again, this A12 is actually going to be that chip select 2. Okay, and that should be all the connections we need. So we can go ahead and run the design rules check. Just make sure everything's hooked up correctly. Okay, and so I forgot to do something here. We need to go back into the symbol editor. So we're getting all these errors here about input pins not being driven by output pins. So what we want to do is we want to go back to the symbol editor, close that electrical rules checker, look for our ROM adapter, and we want to select our 2364 socket. And we need to go back into the pin table. And so what we need to do is we need to change the electrical type of all of our address pins from inputs to outputs. Since this isn't really representing a chip exactly, it's actually representing the electrical connection from the computer bus, and the computer is going to be driving those address lines, so they're effectively going to be outputs rather than inputs. We can leave the data lines as tri-state. Ground, we need to change this from power input to power output. Address lines, change those to output. Chip select is going to be an output. And finally, the VCC, we change this from power input to power output. Okay. Go ahead and save that. Does that update it automatically? No, it did not update it automatically. So we have to update symbol from library. Okay, close. And now we should be able to run that design rules check again. And finally, we pass with no errors, so we're good to move on. Oh, and I also want to change I want to assign a footprint for this solder jumper. So for the solder jumper, I'm going to use the square pins with a little mark on pin 1. Now for the 2364, what we need to do is we need to create a new footprint for this. When I created this symbol, I just assigned the dip socket to it. But what we actually need is we need to assign 2 rows of pin headers to it. Because we need something that's going to plug into a socket that's on the Commodore 64 board. So we go into the footprint editor, and again, we have to create a new library inside of our project. And I'm going to call it ROM adapter again. And I want to look for pin headers. So because we're working with a 24-pin chip, we need 2 rows of 12-pin headers. But we want 2.54 millimeter spacing. And I don't want surface mount, I want through hole. So let's see, here we go. 1 by 12, 2.54 millimeter spacing, and vertical. So we're going to take this footprint, we're going to copy it. And we go to our ROM adapter. And we're going to paste that footprint. Okay, And so we want 2 rows of these pin headers. So we'll select this and duplicate. And we're going to move it over 6 spaces. And so now we can check, make sure this pad is at 15.24. That's the spacing that we want for a double width dip socket. Now, if we were designing a dip socket, we would have the numbering start in the upper left corner, go down 1 through 12, and then over here we would go 13 through 24. But because we're making a male pin header that's actually going to be flipped and put on the bottom side of the circuit board, we actually need to flip these 2 rows horizontally. So we're actually going to have 1 through 12 on the right side, and then we're going to come over here and we're going to change these to 13 through 24. So go ahead and change that. Pin 24, I don't need this to be a rectangular pin, so I'm going to change it to oval. And just to make everything neat, I'm going to go ahead and update the silk screen on here. I'm going to get rid of this. We're going to join this corner together, so we see that the Y is at negative 1.27. So over here, we'll change this to negative 1.27. Change the X to negative 1.27. Okay, so now we have a square there. Delete that segment. And we see here that the upper left corner is at negative 1.33. So we'll go ahead and delete that. Make this negative 1.33 and negative 1.33. Move that up there. Change the endpoints. Negative 1.33. Change the endpoint. Negative 1.33. Okay, so now we have a completed squared off corner there. And yeah, that should do it for our footprint. We'll change the name. Call it pin header socket. 2x12. Width 15.24 millimeter. And I'll get rid of the vertical. Okay. So we can close our footprint editor, and we'll go ahead and assign our new pin header socket to our 2364. Okay, and that should do it for our schematic and our footprints. So now we can go to the PCB editor, and we can update our PCB from schematic. And that's going to give us all of our parts that we can place here. And as I mentioned before, we want to make sure that this pin header socket is on the back side of the board. So we select it and press F to flip it over. And we do the same thing for our jumper. Press F to flip it over. And we see that the pads change to blue. And so before I start moving stuff around, I'm going to put it on the 50 mil grid spacing. I think I goofed up the parts already, so I'll need to get these aligned. So I'll move this one first. Drag this one over here, and I'll move. I'm going to align the two like this, so they're just kind of overlapping. And then we'll put the jumper right here in the middle like that. And so before I draw the board outline, I'm just going to do a quick check in 3D to see how everything is lined up. And so for our pin header socket, we have the 3D model on the left side, but it's missing on the right side. Now, that doesn't really matter electrically, it's just kind of for visualization. But I do want to fix that, so we'll go back to the footprint editor. And so to fix the 3D model, we go into the footprint properties, into 3D models. We copy the model that's already there, and we create a second entry. Just paste that, so we'll have 2 of them. But for this one, we're going to change the offset to 15.24 millimeters. It hasn't updated yet, so click there. And so now we have 2 copies of the model just offset by 15.24 millimeters. So I'll go ahead and save that, close the footprint. So now to fix all of the assignments here, we're going to start from the symbol editor. We're going to open up our ROM adapter library. We're going to find our 2364 socket. We go into our symbol properties, and we're going to change the default footprint for this to our new pin header socket. Okay. So we'll update that there. Okay, and then back in the schematic editor, we select our 2364 socket. We click Update Symbol from Library, Update, Save, and we go to our PCB editor. Once again, we update the PCB from Schematic. That should have changed our footprint. Now go into the 3D viewer, and so now we have the correct 3D model for our 2 rows of pin headers. So we can close our 3D viewer. So to draw the board outline, I'm going to drop down to 25 mils, and we select our edge cuts layer, and I'm going to use the Draw Rectangle tool. Just click here, move over here, click again. And so I just realized I actually did this the wrong way around. I want to have the socket be to the right of the pin header. So I'll drag that out of the way. And we're going to move the pin headers to the left, and we'll move the socket to the right. And we'll keep the jumper where it is. So that should look like this instead. Yeah, so doing it this way should make the routing of the power line a little bit easier. So we'll do it like that. And now we can go ahead and start doing the routing. So the routing is going to be pretty straightforward. It's mostly just going to be diagonal connections, but we're going to do those on the back copper layer. And for the last few traces that need to be routed, we'll have to switch over to the front copper layer. This one will go right down the middle, and this one go around that way. And that should be all of the traces routed. So we'll run our electrical rules checker, and everything's connected correctly. Now, the last thing I want to do is add some silkscreen labels to just clarify what the purpose of this jumper is. And so I'm going to put that on the back side of the board. So we'll go ahead and flip the board view over. We'll switch over to the bottom silkscreen layer, and I'm going to use the text tool. I'm going to change the width and height to 0.025, centered. First, I'll create a label. We'll call it the Trevor Makes 2364 to 28C64 adapter. Drop that right there. And so now I'm going to use the rectangle tool to copy these footprints here. We're going to select the 3 of those, move that down, duplicate it, and put it down here. Use our rectangle tool again, and we will create another rectangle, which we will fill in this time. And that will represent the left 2 pads getting connected together. Do the same thing down here. Create another rectangle, fill it, and that will represent the left two pads getting connected together. So we'll use the text tool again, and we're going to label the first connection. We'll say this is for basic or kernel at addresses 0 through 1FF, or a C64 character generator at 1000 through 1FF. Okay. Create a second label, and we'll call this one VIC20 character generator at 0 through 0FF. Okay. I'll just move this one down a bit. It looks good to me. View it in 3D. And so that should make it clear which jumpers need to be connected depending on if it's a basic or kernel or a C64 character generator, or if it's being used for a VIC20 character generator. And so the last thing we need to do is generate the outputs. So we'll go to File, Plot, and we need the front copper, the back copper. We don't need the front or back paste. We can unselect those. We do need the front and back silk screen. We do need the front and back mask. And we do need the edge cuts. Output directory, we'll set that to our project folder. I'm going to create a new folder, call it gerbers. Click plot. And then we're also going to click generate drill files. Go ahead and click generate drill file. And close. Now, just to make sure everything went okay, we're going to go back to the main menu and we're going to click the Gerber viewer. Okay, so we'll open our Gerber files. Open our drill file. Open both of those. So everything looks like it's lined up. We don't have any non-plated through holes, so that layer's empty. Copper layers look good. Flip Gerber view. And so all of the Gerber files look good, so we can go ahead and upload these. In the next video, I'll show you how to have the boards manufactured from the Gerber files, and I'll also build and install one in my Commodore 64, along with some other repairs. If you enjoyed this video, don't forget to give a like, comment, subscribe, all that YouTube stuff, and I'll see you next time.